Alright, this is lesson 7.2 of our Pre-Calc 12 class. Unit 7 is Trigonometry. Lesson 2 is called the unit circle. What we're going to do in this lesson is explore the unit circle in terms of radians and just kind of familiarize ourselves with those key benchmarks on the unit circle. So if we take the unit circle and we cut it into 45-degree chunks, we have basically eight sections. I'm looking at this and seeing an 8-slice piece of pizza, but whatever. So 45 degrees is pi over 4. So 2 45 degrees, or 90 degrees, is 2 pi over 4s, or just 1/2 pi. 3 chunks is 135 degrees, will be 1, 2, 3 pi's over 4. 4 chunks, 180 degrees, would be 4 pi's over 4, which is pi. A 5th would be 5 pi over 4. A 6th would be 6 pi over 4, which reduces to 3 pi over 2. One more chunk would be 7 pi's over 4. And one more chunk would be a full circle, 8 pi's over 4. And 8 over 4 is 2, so 8 pi over 4 is just 2 pi. So if we look at this and jump by 45 degrees, we're jumping by pi over 4 radians. And so we just, count 1, 2, 3, 4, 5, 6, 7, 8 pi over 4 and reduce fractions accordingly. If we take our 8-slice pizza and instead cut it into, what would that be, a 12-slice pizza? Each slice would be a 30 degrees chunk, which would make each slice pi over 6 radians. So we have pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7, 8, 9 pi over 6, 10, 11, 12 pi over 6, all the way around. And of course, a lot of those fractions are simplifiable. So like 2 pi over 6, or 60 degrees, I can simplify 2 over 6 to be 1 over 3. So that's also pi over 3 radians. And then 3 pi over 6, 3 over 6 is just 1/2. So 90 degrees is also pi over 2, which is consistent with our 8-slice pizza. So we can basically just take our unit circle and we can cut it into pi over 4s, and those give us some benchmarks. We can cut it into pi over 6 slices, and that would give us more benchmarks. And if we simplify our fractions, well, let me say it this first. If I take both slices of pizza and I cut our pizza into 6, and I go back and for some strange reason cut it into 8 slices, our overlap would look like this. And so this is kind of our benchmark radians on the unit circle. All the 8-slice pizzas and all the 12-slice pizza overlapped. We get those by cutting our pizza into pi over 4 slices and then going back and cutting into pi over 6 slices. And if we reduce the fraction, then what we end up with is radians that have denominators of 2, 3, 4, and 6. Or technically 1 if you include pi and 2 pi. But these are our benchmarks for the unit circle. And so in class, we did an activity to kind of embed these into our minds a little better. And so it is what it is. It's content, it's knowledge, the unit circle. But what we did was kind of a little more just practice familiarizing ourselves with intricate details of the unit circle. And so it is a liturgy of math, if you will. And what the activity would do, and if you want to recreate this at home, here's how we do it. Write this down on a piece of paper or a whiteboard. Everything you see here, the unit circle, and then blah, all the degrees, all the radians, all the lines on the circle. And then once you got it down, I want you to erase or throw the paper, like crumple it, make a snowball, chuck it across the room, and then try it again. And now I want you write it the exact same way as last time, except that now this cheat sheet that we have right here is well, we're missing 4 pieces, so make sure you write those 4 pieces in the way you did the first time. And so I guess to say, at this point, if you're doing the activity, pause the video, write this down. Last chance to pause the video before we move on. Write it down. Okay, and in case you're wondering, those are those missing pieces right there. And so take that piece of paper, crumple it down, get a new piece of paper, and when you're ready, try it again. Again, this is a good time to pause the video, write all the stuff, the whole unit circle down, all the degrees, all the radians. Last chance to pause. Okay, you can check your work by looking at your last piece of paper, or you can pause the video right here, and here's the answers. Okay, round 3, new piece of paper. Are you ready? Here you go. Try it again. Feel free to pause the video, so I'm going to move on. When you're ready, check your answers. Here they are. Which ones are easy to do? Which ones are difficult to remember? Also, do you notice any patterns? Alright, new piece of paper. Are you ready? Round 4. Try it again. Write it all down. Pause the video because I'm going to move on. And then when you're done, here are the answers. Check your work, make sure you did it all correctly. It would totally suck if you started copying down the wrong answers and memorized the wrong answers. Because then it would be, not only we have to memorize the right answers still, but you have to get those wrong answers out of your head. What we're doing is like I said, this is a liturgy of sorts for math class. We are doing repetition. We're scratching the unit circle on the inside of our skull, so it will stay with us forever. Okay, round 5. Are you ready? New piece of paper? There you go. Write down the unit circle, all the degrees, all the radians for our benchmarks. Go ahead and pause the video so you can do that. Last chance to pause. Alright, so here are the answers again. Here's all of the benchmarks in degrees and radians. Did you notice any new patterns this time around? When is the denominator 2 versus 3 versus 4 versus 6? That could be a pattern. Alright, round 6, new piece of paper. Are you ready? Alright, go. Write them all down. I find it helpful to go and do the pi over 2's maybe, and then go back and do the pi over 4's, and then go back and do the blue lines, the pi over 6's. Or you can just do all the pi over 4's, and then do all the pi over 6's, and then reduce the fractions. That works too. Or you notice that as the, well, last chance to pause before I give more patterns away. Alright, here we go. Here are the answers. Notice that the closer we get to the top or the bottom, the smaller the denominator. Notice the closer we get to the middle, the bigger the denominator. So like 6, 4, 3, 2, 6, 4, 3, 2, 6, 4, 3, 2. Yeah. I just noticed that pattern for the first time. Like right now, I just noticed that. Crazy. What patterns am I missing still? I don't know. New piece of paper. Last try. Round 7. Are you ready? Okay. Try it out. Pause the video. Try doing the unit circle. Last chance to pause before we move on. Alright, here are the answers. If you wanted to do one more round, like, just turn your computer screen off or just close your laptop for a moment, put your cell phone down, just try doing it without the template. See if you can do it from memory. next level, fancy poo. Give yourself 10 minutes, go do something else other than math. After 10 minutes, come back and try doing it again. And then even next level, tomorrow morning, first thing, wake up, set an alarm. Try doing it first thing in the morning when you wake up. Yeah, try it. Dare you. Come on now. All right. So, here we go. So hopefully you have a little more confidence looking at the unit circle and knowing your benchmarks in degrees and radians. Here's some example problems. So in the last lesson we went from degrees to radians. In this lesson we'll have an assignment where we have to go from radians to degrees. So you could use that formula, radians times 180 divided by pi would give you back to degrees. But this time, since we know our benchmarks, we can reason from there. Our benchmarks are all pi's over 2's, over 3's, over 4's, or over 6's. So if we know that pi over 2 is 90 degrees, 3 pi over 2 is 3 times pi over 2, which in degrees would be 3 times 90, or 270 degrees. Yeah? See how easy that is? Pi over 3 is 60 degrees, so 7 pi over 3 would be 7 times pi over 3, or in degrees would be 7 times 60, or 420 degrees. Not bad, eh? If pi over 4 is 45 degrees, then 11 pi over 4's, it would be 11 times pi over 4, which in degrees is 11 times 45, because pi over 4 is 45. And then 11 times 49, 495. If pi over 6 is 30 degrees, then 5 pi over 6 would be 5 times pi over 6. 5 times 30 is 150. Yeah, and then 10 pi over 3 would be 10 times pi over 3, which would be 10 times 60 degrees, which is 600 degrees. So we can use that formula. 180 divided by pi gives us from radians back to degrees. Or since we know our benchmarks now, we can use our benchmarks to kind of reason with this. It gives us the same answer either way. It's just a quicker way of thinking about it. And the truth is, the more ways you understand it, the better you understand the whole concept, right? So that's that. Good luck with your assignment.